66 million years ago, on just another ordinary sunny morning, the most successful animals that had ever walked the face of the Earth came face to face with the apocalyptic end to their way of life known as the KPG or KT extinction. They were to become the last dinosaurs that would ever walk the face of the Earth, outside of a movie screen, that is. The world at the very end of the Cretaceous period was totally remarkable. The Cretaceous era had seen an explosion in the variety of living species of the terrestrial ecosystems that appears truly dizzying in scope, even judging from just the admittedly incomplete fossil record that we have to go by. 66 million years. The Cretaceous period had been running for 79 million years at that point, making it the longest stretch of the Mesozoic era. These animals had already outlasted nearly 80 million years of changing conditions. Seasons, climate shifts, sea level changes, volcanic activity. Dinosaurs had adapted and diversified and filled every ecological niche imaginable. There were hundreds of species spanning every continent on the planet. They were not some struggling, irritating group of tiny proto-mammals or synapsids. They were dominating. The continents during the late Cretaceous had drifted significantly farther apart than the old supercontinent configurations. North and South America had mostly separated, and Africa, Australia, and Greenland had recognizably familiar outlines by this point. Europe and Asia were still taking shape. Mountains were actively forming, including the early stages of what would eventually become the Rockies in North America and mountain ranges across Mongolia and other parts of Asia. Sea levels were dramatically higher than today, and shallow inland seas actually covered large portions of North America, Europe, and other landmasses. The world was assuming a familiar outline through these end Cretaceous terraforming events. Climatically, the late Cretaceous was warmer than today, though it had been cooling somewhat compared to earlier in the period. By the very end, there were actually ice caps forming at the poles, and in high-latitude places like Alaska, winter temperatures could plunge severely. But overall, the planet remained significantly warmer than modern Earth. Flying reptiles called pterosaurs still ruled the skies, some with wingspans of roughly 15 meters. Lush forests blanketed enormous stretches of the continents, and by the end of this evolutionary period, flowering plants had even evolved. Conifers, ginkgo trees, and ferns had dominated for ages, but now angiosperms were spreading, changing the texture of the world. Bees and butterflies had developed symbiotic patterns of interacting with these new flowering and fruiting plants that were developing. The whole food chain had expanded and become more interconnected and complex. Dinosaur species thrived in this new abundance. Late Cretaceous life featured a staggering diversity of forms. On the smaller end of the spectrum, there were creatures that were barely larger than a modern bird. Some were genuinely tiny, with skulls only a few centimeters long. At the opposite extreme, you had the enormous titanosaur sauropods, some of the largest land animals that have ever existed on this planet at any point in history, with bodies stretching nearly 30 meters and weights that could push up toward 40 tons. These colossal herbivores needed to consume roughly a ton of plant material every single day just to sustain themselves, which meant they were constantly on the move through the forests, stripping trees and moving on before the vegetation could be completely exhausted, clearing overgrowths and reseeding many plant species in this perpetual migratory cycle. When we think about dinosaurs, many people think about North America, about creatures like Tyrannosaurus rex and Triceratops. But the late Cretaceous did not just happen in North America. It was a worldwide phenomenon. Every single continent on Earth, including Antarctica, had its own unique cast of dinosaurs, each one shaped by its local environment, its local prey, its local pressures. And some of the most bizarre, most spectacular, most flat-out mind-bending dinosaurs are at times completely ignored, it seems. So today, I intend to specify the names of some of the most unusual or noteworthy dinosaurs at the end of the Cretaceous on each continent. North America during the late Cretaceous was essentially two separate landmasses divided by a massive inland sea called the Western Interior Seaway. This shallow ocean stretched from what is now the Gulf of Mexico all the way up to the Arctic, splitting the continent almost entirely down the middle for much of the time. On the western side was the landmass called Laramidia, and this is where most of the iconic dinosaurs we know and love actually lived. The eastern side, called Appalachia, was more isolated and had its own unique fauna, though the fossil record there is much more fragmentary. In Laramidia, you had ecosystems that were absolutely packed with large, spectacular animals like Tyrannosaurus rex. But even within the Tyrannosaur family in North America, there was incredible diversity. Earlier in the late Cretaceous, animals like Albertosaurus were hunting in what is now Canada, and there's actually fossil evidence suggesting these animals may have been social hunters, with multiple individuals found at the same site. In North America, you had the iconic Tyrannosaurus rex, which at this late stage in the Cretaceous was arguably at its true evolutionary peak. This animal weighed up to roughly 7 tons and was equipped with one of the most powerful biting forces of any land predator ever. Its vision was extraordinary, with binocular sight sharp enough to rival birds of prey, allowing it to accurately judge distances to potential meals. Its sense of smell was exceptional, even by dinosaur standards. This was an apex predator that had been refined by millions of years of evolutionary pressure into a terrifyingly apex-efficient predator. Also in North America at this time were animals like the Pachycephalosaurus, medium-sized dinosaurs with distinctive thick-bone domes on their skulls up to about 25 centimeters thick, likely used in territorial or competitive behavior. These creatures were primarily plant eaters, but may have supplemented their diet with small animals. And then there was the Ankylosaurus, a beast roughly the size of a small elephant, completely armoured in bony plates along its back and sporting a massive club tail that could shatter bone. Despite this fearsome appearance, Ankylosaurus was an herbivore, using that armour and weapon purely defensively. Toward the very end of the Cretaceous, T. rex became the dominant predator in most regions of Laramidia, while Nanoxaurus, a smaller tyrannosaur, roamed the Arctic regions. Nanoxaurus lived inside the Arctic Circle, dealing with polar winters and dramatically changing light levels throughout the year. But the predators are only half the story. The plant eaters of Laramidia were extraordinary. The hadrosaurs, or duck-billed dinosaurs, were probably the most successful large herbivores of this time and place. Edmontosaurus could reach lengths of over 12 meters and likely traveled in vast herds across the floodplains. Parasaurolophus had that extraordinary hollow crest running along the back of its skull, and scientists now believe this crest functioned like a resonating chamber, allowing these animals to produce deep, resonant calls that could travel long distances through dense vegetation. Imagine a low, haunting sound drifting through the Cretaceous forest. That was Parasaurolophus, communicating with its herd. Then you have the ceratopsians, the horned dinosaurs, which reached their evolutionary peak in North America during this period. Triceratops is the most famous, but it actually lived during the last few 100,000 years before the extinction event. Before Triceratops, there was an explosion of ceratopsian diversity that is genuinely staggering. Styracosaurus had an array of spikes radiating from its frill that looks almost alien. Pachyrhinosaurus had a huge bony boss on its nose instead of a horn, and evidence suggests these animals migrated seasonally in enormous herds, possibly following the movement of vegetation through the seasons. Ankylosaurus, which also lived right at the end of the Cretaceous, was basically a living tank. Its entire body was covered in thick, bony plates embedded in the skin, called osteoderms, and at the tip of its tail it carried a massive club of fused bone that could potentially break the leg bones of an attacking dinosaur. Life during the Cretaceous was not composed of passive creatures waiting to be eaten, despite hadrosaurs at times being pejoratively referred to as the cows of the Cretaceous. They were active defenders with genuine weapons. If we now cross an inland sea to Asia, we find that the Tarbosaurus filled a role similar to the T-Rex, being among the largest predatory dinosaurs on that part of the globe, a 14-meter predator hunting floodplain ecosystems and river valleys for prey. During the late Cretaceous, Asia was a very different place geographically. Parts of what is now Central Asia were warm and relatively dry, while regions like Mongolia had seasonal environments with periods of intense drought followed by floods, which is actually why so many fossils are preserved there. The Gobi Desert in Mongolia has been one of the most productive fossil sites on the planet for over a century, and the animals recovered from there are absolutely spectacular. Tarbosaurus batar was the apex predator of late Cretaceous Mongolia, and while it was closely related to T-Rex, there were differences in the skull shape and proportions. Tarbosaurus had an even more narrow skull than T-Rex, which some researchers think indicates slightly different predatory behaviors or prey preferences. It also had relatively even smaller forelimbs in proportion to its body than T-Rex, which is saying something given how reduced T-Rex arms already were. Asian dinosaur fossils in the late Cretaceous show an incredible diversity of feathered and bird-like dinosaurs, and animals from this region are giving us some of the most important clues about how birds evolved. Oviraptorosaurs were particularly diverse and abundant in Mongolia. Oviraptor itself was famously mislabeled as an egg thief when it was first described, because early fossils found near it were thought to be Protoceratops eggs. We now know those were actually its own eggs, with Oviraptorosaurs being apparently devoted parents, sitting on their nests in a posture very similar to modern birds. Sittipati, a larger oviraptorid from Mongolia, has been found in this brooding posture with its arms spread over a clutch of eggs, essentially proving that this behavior was present in non-avian dinosaurs long before modern bird brooding postures evolved. Then there were the dromaeosaurids, the raptors, which we all know from North America and the movies. Evidence points to Velociraptor as actually being a relatively small feathered animal, about the size of a large turkey, with its size increase largely attributed to the fact that in movies many of its attributes, especially size, are actually borrowed from the closely related dromaeosaurid, Deinonychus. The real animal was covered in quill-like feathers and was roughly knee-high to a human adult, but what it lacked in size, it may have made up for in the same way that modern predatory birds make up for their small size through speed, agility, the element of surprise, and their sheer ferocity. Anyone ever unexpectedly come across a migratory sandhill crane in North America? If so, I rest my case on the potency of bird-type jump scares. Evidence from a famous fossil called the Fighting Dinosaurs shows a velociraptor and a protoceratops locked in combat, apparently buried together in a collapsing sand dune mid-fight, preserving a single terrifying moment from 66 million years ago. The sauropods were in decline in the northern continents by the late Cretaceous, but they were still present. In Asia, titanosaur sauropods coexisted with all these other groups, adding yet another layer to these already complex ecosystems. During the late Cretaceous, South America was an island continent, isolated from North America for much of this period. This isolation meant that the dinosaurs of South America evolved on their own separate trajectory, producing animals with no close equivalents anywhere else in the world. The sauropods of South America regularly seem to have reached unbelievable sizes. The titanosaur sauropods reached their greatest extremes on this continent. Patagotitan maiorum, described from Argentina in 2014, is one of the largest animals to ever walk the Earth, with some estimates suggesting it may have weighed over 60 tons. Picture an animal over 30 meters long, walking slowly through the Patagonian landscape. The scale of these animals alone is almost impossible for one to process. But South America also had its own unique predatory dinosaurs, the abelisaurids. These were medium to large theropods, and they had a fascinating and slightly disturbing appearance. Their arms were even more reduced than those of tyrannosaurs, often to the point of being almost vestigial, with tiny, nearly functionless hands. But their skulls were often heavily ornamented with horns and crests and rough-textured bone, giving them a fierce and unusual look. Carnotaurus from Argentina is probably the most famous abelisaurid, with those distinctive bull-like horns projecting from above its eyes. This animal also appears to have had relatively large eyes and was possibly a fast runner for its size. The abelisaurids weren't just in South America, though. The dinosaurs of the late Cretaceous world echo the ancient connection between South America, Europe, Africa, and India through the legacy of the ancient supercontinent Gondwana. These landmasses had been connected much earlier in Earth's history, and the sharing of animal lineages between them tells an extraordinary story of ancient geography. In what is now Morocco and Egypt, we have evidence of large theropods and titanosaur sauropods living along ancient river systems and coastal environments. The ecosystems of North Africa during this time were dramatically different from today. Instead of the Sahara Desert, there were vast river deltas teeming with fish, crocodilians, and enormous dinosaurs. Spinosaurus, while technically known from the earlier Cretaceous, is associated with North African environments, but by the late Cretaceous, other large theropods were taking over these ecological roles. Carcharodontosaurid theropods, enormous meat-eaters with serrated blade-like teeth, somewhat resembling those of sharks, were among the dominant predators in some African environments. The titanosaurs of Africa were also incredibly diverse, and some of them show fascinating connections to their South American relatives, echoing that old Gondwanan legacy. Africa's isolation during parts of the Cretaceous allowed for the evolution of unique lineages that we're really only beginning to understand as new fossils come to light. Europe during the late Cretaceous was an archipelago, a collection of islands in a warm, shallow sea. And island environments do something very interesting to large animals over evolutionary time. It tends to make them smaller. This process, called insular dwarfism, produced some of the most extraordinary dinosaurs ever discovered. On the islands that made up late Cretaceous Europe, large dinosaurs were rare. Instead, you had relatively small sauropods, essentially titanosaurs that had shrunk over generations to a fraction of the size of their continental relatives. Magyarosaurus from what is now Romania was a titanosaur that grew to only about 6 meters long, which sounds big until you compare it to its 60-meter-long relatives elsewhere. Research on the bone structure of Magyarosaurus has confirmed that it truly was a small adult animal, not a juvenile, and that island dwarfism had fundamentally changed its growth patterns. But Europe also had some unusual predatory dinosaurs. The rhabdodontids were a group of plant-eating dinosaurs related to iguanodonts that were particularly diverse on European islands, having evolved in isolation from the larger predators that might have kept their populations in check elsewhere. Abelisaurid theropods also appear in European faunas, harkening back to that Gondwanan connection story. And then there's Hateg Island, in what is now Romania, which has produced some of the most extraordinary fossils in the entire late Cretaceous record. This island had giant pterosaurs, including Hatzegopteryx, which is one of the largest flying animals to ever exist, with a wingspan possibly approaching 10 to 11 meters. Hatzegopteryx was a very ironic find given the context of the evolution of other creatures on Hateg Island. Because the island had no large predatory theropods, Hatzegopteryx may have filled the ecological role of apex predator itself, essentially functioning as a gigantic, ground-stalking carnivore when it wasn't flying. They are speculated to have been walking around on all fours and using their enormous beaks to hunt relatively small prey on an island where nothing else was playing that ecological role, much like Quetzalcoatlus has been described as doing elsewhere. Now let's cross to a continent that almost never gets mentioned in dinosaur discussions, but absolutely should. Australia. During the late Cretaceous, Australia was still connected to Antarctica as part of the remnant of ancient Gondwana, though it was in the process of separating. The position of Australia meant that the southern parts of the continent were within or near the Antarctic Circle, experiencing polar winters with months of darkness. The dinosaurs that lived there were therefore genuinely polar animals, adapted to dramatically seasonal environments. The dinosaurs of late Cretaceous Australia are known from relatively few specimens, but what we have is intriguing. The hypsilophodont dinosaurs of Australia, small to medium-sized plant eaters, appear to have been adapted for life in low-light seasonal environments. There's been significant scientific discussion about whether these animals were warm-blooded in a way that would have allowed them to remain active during the dark polar winter, or whether they migrated or hibernated. The bone growth patterns of some of these animals suggest they were indeed capable of sustained active growth in cold conditions, implying physiological adaptations quite different from stereotypical reptilian cold-blooded models. Australia also had its own large theropods, though the fossil record is frustratingly incomplete. Evidence of large theropod footprints found in Western Australia suggests that sizable predatory dinosaurs were present, but finding the actual bones has proven difficult. The Australian fossil record for this period has one of the most significant gaps in our understanding of global dinosaur diversity. During the late Cretaceous, Antarctica was not the frozen wasteland it is today. It was still cold by the standards of the time, and it had seasonal extremes, but the continent was forested, with significant vegetation supporting animal communities. Temperatures were dramatically warmer than today's Antarctic conditions, and the continent was home to a range of dinosaurs and other prehistoric animals. Fossils from Antarctica's James Ross Island and the Vega Island area have revealed a fascinating fauna. Hadrosaurs, those successful duck-billed dinosaurs that were so diverse in North America, appear to have made it all the way to Antarctica. The discovery of hadrosaur fossils in Antarctica was significant because it suggested that these animals were capable of crossing between continents in ways that required understanding the connections between land masses in the late Cretaceous world. Ankylosaurs have also been found in Antarctica, again showing connections to the broader global fauna of the late Cretaceous. And Antarctica had its own unique animals as well. The nothosaurs and plesiosaurs of the surrounding Antarctic seas were extraordinary creatures, though those are technically marine reptiles rather than dinosaurs. The presence of all these animals in Antarctica speaks to just how dramatically different this planet looked 66 million years ago. Let's zoom out for a moment and think about the big picture of the late Cretaceous world, because there's something genuinely profound here that often gets lost when we focus on individual animals. The late Cretaceous demonstrates an absolute peak of dinosaur diversity. These animals had been evolving for over 150 million years by this point, and they had colonized every continent, every major environment type, every ecological niche from the tropics to the poles. Many were very clearly warm-blooded, or at least had elevated metabolic rates in many lineages, along with complex social behaviors, from the herding migrations of hadrosaurs and ceratopsians to the nest-guarding behaviors of oviraptorosaurs. Many dinosaurs of a variety of types had elaborate display structures, crests and frills and horns and tail clubs that suggest rich social lives involving communication, competition, and recognition of individuals within species. Thousands of kilometers from the impact site, many theories state that some animals did survive by sheltering in burrows and caves. A Tarbosaurus or two may even have genuinely made it through the initial catastrophe, given their distance from the impact site, but surviving the impact itself was only the beginning. What followed was something scientists call impact winter. The dust, ash, and soot that had been launched into the atmosphere by the impact, and subsequent volcanic eruptions formed a dense global blanket that blocked out sunlight almost completely. Midday became as dark as midnight. This darkness lasted not just for a few days, but for months, possibly years. Without sunlight, photosynthesis stopped, and the plants died. The food chain collapsed in on itself from the bottom up, with herbivorous dinosaurs starving first, rapidly followed by the carnivores, who dined on them. Next up in the queue was the acid rain. Hundreds of billions of tons of sulfur compounds catapulted into the atmosphere during the impact, with the resulting volcanic eruptions combined with atmospheric water to produce sulfuric acid that rained down globally for weeks. It poisoned freshwater sources, sterilized soil, and chemically stripped the landscape of whatever initial recovery might have been starting. When the handful of creatures who had survived the initial hours finally emerged from their hiding places, they encountered a world that was cold, dark, silent, and empty. The global temperature had dropped by around 28 degrees Celsius from the impact-triggered cooling. The familiar forests were gone, replaced by ash and frozen barren ground. The only things growing were fungi and molds that could survive without sunlight. The dinosaurs that made it past that first day could not live for long with no possible sustenance to speak of. Whatever tiny groups might have hatched from preserved eggs found nothing to eat in the devastated landscape. Disease, cold, and starvation claimed the survivors over the months and years following the impact. The last non-avian dinosaur on Earth died alone in a changed world. The Chicxulub crater itself, lodged beneath the Yucatan sediments, stretches 180 kilometers in diameter. Across the entire world, in geological layers precisely dated to 66 million years ago, scientists have found elevated concentrations of iridium, an element extremely rare on Earth's surface but common in asteroids. This layer, often called the KT boundary layer, exists on every continent, everywhere on the planet, and at the bottom of every ocean. It is the fingerprint of a single catastrophic global event. Not long ago, fossil deposits in New Jersey were found containing thousands of animal remains, all dating to the same day at the end of the Cretaceous, representing another snapshot of the KT boundary extinctions. Approximately 80% of all animal species on Earth vanished at this boundary, and not just dinosaurs. The great marine reptiles like plesiosaurs and mosasaurs disappeared. Ammonites, those beautiful spiral-shelled creatures that had filled the oceans for hundreds of millions of years, went totally extinct, along with flying pterosaurs. The skies, the seas, and the land all lost their usual inhabitants in one geological instant. Somehow, a few relatively small creatures did survive this apocalypse, though. Crocodilians, turtles, and a number of lizards and snakes lived on. Crucially for the human story, many small mammals that had been living in the shadows of the dinosaurs throughout the Cretaceous emerged into the post-impact world as survivors. Birds, themselves descendants of certain dinosaur lineages, also made it through, so technically speaking, dinosaurs did not go completely extinct, taxonomically speaking. They just went extinct in every other way that we think of the species as existing. Over the following decades, as the dust clouds slowly dissipated and sunlight finally penetrated back to the surface, the first survivors were ferns and horsetails, then gradually more complex plants that were eventually followed by flowering trees and grasses. Mammals expanded into every ecological role left vacant in the new ecosystem, growing larger and more diversified over tens of millions of years, eventually giving rise to primates, and eventually to Homo sapiens. Dinosaurs dominated this planet for over 160 million years. Humans have existed in something resembling our current form for approximately 300,000 years. It is therefore difficult to call dinosaurs a failed experiment. They were an overwhelming success story that happened to meet the one type of catastrophe no adaptation can prepare you for: a rock from space arriving without warning and with no possibility of evasion. They were a profound biological achievement up to that point in history. Roughly 66 million years ago, a space rock approximately 10 kilometers across was on a collision course with Earth after traveling through the solar system for what was probably an immense period of time. And it was around the size of a mountain. As it entered the atmosphere, gravitational forces accelerated it to extraordinary speeds, around 20 kilometers per second, and the friction of pushing through the air heated it to tens of thousands of degrees, making it shine far more intensely than the sun in the sky above. The impact point was in the Gulf of Mexico near the coast of what is now the Yucatan Peninsula in Mexico. When that 10-kilometer object struck, it penetrated roughly 20 kilometers into the Earth's crust before vaporizing entirely. The energy released was equivalent to billions of atomic bombs going off simultaneously. The scale of this is genuinely difficult to process. For comparison, when the Krakatoa volcano exploded in 1883, it ruptured the eardrums of sailors on ships 70 kilometers away. The asteroid impact was estimated to have been around 1,000,000 times more powerful than Krakatoa. This was not just a large explosion, it was a planetary-scale catastrophe from the first microsecond of contact. The shockwave that radiated outward from the impact point travelled faster than the speed of sound. Animals hundreds of kilometers from the impact site were lifted off the ground, flung through the air, and crushed. The heaviest dinosaurs were hurled like toys. The T-Rex that had been feasting just moments before sustained a fatal concussion and was dead almost instantaneously as the shockwave reached it, its body briefly airborne before crashing back down. A giant sauropod herd near the Yucatan coast is sometimes described as having been obliterated before any other creature on land. They were simply too close. The heat was so intense, it reduced everything to ash. Not just dead, erased, gone without a trace. Hundreds of kilometers away in the North American forests, other creatures died even before some creatures closer to the actual impact site did. That is because as the asteroid blazed through the atmosphere, it triggered enormous fires along its entry path. Forests of trees ignited almost instantly, leaving no escape possible. Meanwhile, the asteroid impact itself excavated an unimaginable volume of rock from the Earth's surface. Estimates put the figure around 15 trillion tons of debris launched into the atmosphere and even into space. The material that did not escape Earth's gravity began raining back down. Boulders the size of houses fell back from near-orbital heights, and with them came a rainfall composed of superheated glass fragments, tiny molten pellets of rock that showered the planet globally. Everything caught fire. Continent-wide wildfires consumed forests that had been building for millions of years. These fires and falling rock were not the only causes of death. Some creatures survived those initial horrors, only to face tsunamis caused by the impact that had transferred an inconceivable amount of energy into the ocean. This triggered tsunamis of extraordinary scale. These waves reached estimated heights of around 100 meters, which is roughly 10 times larger than the devastating 2011 Japan tsunami that caused catastrophic damage across that entire island nation. The Cretaceous tsunami, though, didn't just crash onto coastlines. It drove inland across what is now the entire United States, with wave evidence being identified as far inland as modern North Dakota. The earthquakes triggered by the impact were also unlike anything the planet had experienced in living memory or would experience again. Estimates place them at around magnitude 11, roughly 50 times more energetic than the largest earthquake ever recorded by modern instruments. These seismic waves traveled the entire globe multiple times. Every volcano on Earth responded. Calderas that had been dormant woke up simultaneously. Around 70 billion tons of pulverized rock, soot, ash, and gases were hurled into the upper atmosphere. The late Cretaceous world was not a doomed world. It was a thriving, complex, extraordinarily rich biosphere that simply ran out of luck on one very specific morning. The animals that died were not failed by evolution. They were the products of 160 million years of successful adaptation and were the masters of their planet. And in the end, all it took was just one rock, albeit a colossal rock. The late Cretaceous is a world that rewards curiosity, and we have only scratched the surface.